This is assignment number 2 for the class Intelligent Systems, Robots, Agents, and Humans. The topic is reinforcement learning, and we explore the Q-learning algorithm. I have used the Python programming language to develop my program, and we're gonna put it to the test. The file is Q-learning with the extension py. We run the program and we see our menu. The menu has the low grid layout as the first option. We're gonna load the grid layout and then we'll explain the following options. As the grid layout, we have an ASCII file which represents 10 by 10 grid world environment. In my case, is 12 by 12 because I put a wall around the layout. As we can see, the number 0 represents the wall or an obstacle cell. Number 1 means the cell is available. Number 2 is the starting state. Number 3 is the goal state. We have different layouts, and we're going to start with the first layout. As we can see, we have a visual representation of our text file, which is gray cells represent walls or obstacles. White cells represent available states. The yellow cell represents the starting state, and the green cell is the goal state. Our parameters show that we can drive the program based on the total number of episodes. By default, we have 800 episodes. Our alpha is 0.1 and gamma parameter is 0.9. We have two different Q-learning policies, epsilon greedy and softmax policy. The epsilon greedy policy has a parameter epsilon, which is in this case 0.1. All these parameters can be easily changed and tested. We're going to start with the default parameters and just run our Q-learning algorithm. As we can see, the Q values start to change on the screen, and also the heat map. Higher values have a darker color and lower values have a lighter color. Values that are closer to the goal state are higher, and the further you are from the goal state, you're lighter. As we can see, the Q-learning algorithm has ended, and we can actually put it to the test. We can start at, say, column 8, row 10. We put those parameters, 8 and 10, and we find our sequence. And as we can see, the agent was able to reach the goal state. This agent moves in this stochastic world, so we can see at times it has some deviation, but it's able to recover and come up and find the end. We can also try a different action sequence. In this case, we're going to try starting from column 10, row 4. So if we put those values, 10, row 4, we run our sequence, we see the agent is successfully at finding the goal state. Besides the Q values, showing the Q values and the heat map, I've added statistics. We can see a reward chart. If we think about this, our loop has max limit on the number of states, which is 150 steps. Meaning if the agent wanders through the world and is not able to reach the state, every move represents a -1, which over time will accumulate minus 150 points as the worst reward. The best reward would be if the agent starts right next to the goal state and in one move reaches the goal state, he will get 100 points. So our ranges for the rewards in each episode starts from minus 150 to 100. As we can see in this chart, at the beginning, the agent wanders the world learning, and over time, it minimizes, it maximizes the reward and it reaches convergence. We also have the steps chart. which is just it's inverse proportional to the reward, meaning in the beginning the agent explored, so it spends 150 steps, but over time it minimizes the number of steps. We can load a second layout just for visual purposes. In this case, the starting state is on column 2, row 11. Goal state is on column 11, row 2. We're going to try our softmax policy and run our Q-learning algorithm. Same as before, the Q-learning values are changing and our gradient, our heat map is also updating. One difference from our previous policy is that the colors are smoother. The transition in softmax are smoother in terms of Q values. As we can see, the algorithm just ended and we're going to put it to the test. In this case, we're going to start in column 3, row 10. So column 3, row 10. And we can see that the agent is able to find the sequence and reach our goal state. We're going to do a second one, say at column 2, row 4. Column 2. Row 4, we find our sequence, and again, where the agent is able to reach the goal state. Same as before, we have our reward charts. In this case, we can see that the agent explore for, say, close to 700 episodes, and then it quickly converged. As we see the number of steps, similar to our previous case, the steps start to minimize after the 700 episode. One last sample that I like to show is I prepared this grid world, which is interesting because it has our grid layout, but it has a room in the center with an entrance, but it's a dead-end place basically. As a human being, you would actually go, you choose this path or the opposite path, but you will avoid coming inside the room because we see that it's not going anywhere. We're going to put our Q-learning algorithm to the test. We're going to increase the number of episodes. We're going to stay with our softmax policy. We're going to run Q-learning. As we can see, just as before, the numbers are being updated. Our heat map is being updated as well. One specific trend stands out. We can see that the values closer to our goal state have a darker shade. But if we concentrate on the room in the center, we see that the Q values are actually on the negative side, very low values. And if we look at the color, very light, just by looking at the heat map, you would know that the agent will avoid going inside, and just as a human being, it will follow an alternative path. We're going to put it to the test. Let's say this time we're going to start in column 5, row 10. Column 5, row 10. And then we find our sequence, see that the agent is able to successfully go to the find the goal state. We'll do a second action sequence starting at column 2, row 7, 2, 7, and we find our sequence. And we see that in this case, although it's stochastic and we have different moves, it's able to find the goal state. We can actually place our agent inside the room. Let's say we choose column 8, row 5, column 8, row 5, and we find the action sequence, and we see that the agent is capable of actually finding the way out and reaching the goal state. This ends the presentation. Thank you very much.